Okay, today I want to finish up 10.1. I want to talk about two things, the law of independent assortment, and apply that to a dihybrid cross, and then take a look at the probability, multiple probabilities. So, first of all, what's the law of independent assortment? Each pair of factors segregates or assorts itself independently. So as long as they're on separate chromosomes, which the example here they gave, taking a look at seed shape as one type of genetic trait and seed color. So taking a look at both of those at the same time. So if you take a look at a heterozygous for both traits, and in this case, crossing it with another heterozygous for both traits. When you do a dihybrid cross, monohybrid is, say when we were taking a look at tall and short, you always have two traits from each parent. And from that, you're going to end up with two traits. And again, it was from one from each parent. Well, I'm taking a look at the two traits here for seed shape and the two for seed color. So, since the law of independent assortment says that they can assort in any way, shape, or form, I'm going to take this trait with that one, that's here, and then again that first capital R with this second combination of seed color, which is right here. Now that's the only two possibilities I can have with that first allele. So then I have to do the second, the same thing with that second one. The small r in this case can be with the capital Y, or it could be with the small y. Now those are all the possibilities that I can have. I can get no more, I can get no less in a in a normal situation. And then they did the same thing down the side with the other parent. Capital R with capital Y, capital R with small y. Then small r with capital Y, and small r with small y. So when you're done, this is all the possible combinations. This is all the possible combinations I can have for the offspring. And not so easy to do the percent, because up here, it's easy to say small t is 25%, and capital T, small t is 50%, or 2 out of 4. So here we'll just go out of 16. So the probability that it will be round yellow is 9 out of 16. Or round green is 3 out of 16. Or wrinkled with yellow is 3 out of 16. Or wrinkled with green is 1 out of 16. Okay? So the probability, if I mate these two together, that the first seed, it'll be 9 out of 16 for this, or 3/16, 3/16, and 1/16. Okay, now I want to take a look at probability. So if I take something simple, let's say that I'm looking at, what are the odds that I'm going to have a girl first? Well, it's 1/2. You got two possibilities, a male or female. So to have a boy is 1/2. Well, what would be the probability that I will have two boys in a row? Well, the first one would be 1/2, and the second one would be 1/2, and you multiply the probabilities. So in this case, it would be 1 out of 4. My sister had 5 girls in a row. Before she started, if you said, what are the probabilities that you'd have 5 girls in a row? It would be 1/2 for the first girl, 1/2 for the second, third, fourth, and fifth. 2, 4, 8, 16, 32. 1 out of 32. Okay? Now, at any point in time, let's say you already have a girl. What's the odds your next one's going to be a girl? It's 1/2. It doesn't matter what happened before. If you had 4 girls in a row, or in this case, if you had 5 girls in a row like my sister did, what are the probabilities the next one's going to be a girl? 1/2. Actually, they had another child, and it was a boy. Okay? If I take a look at this, we looked at aneuploidies last chapter. For a 25-year-old female, the odds of having a child with Down syndrome is 1 in 1,200, an aneuploidy. So if I said, what are the odds I'm going to have a girl with Down syndrome, and my wife is 25 years old? Well, the odds of having Down syndrome is 1 in 1,200. The odds of it being female is 1 in 2. So the odds of me having a girl with Down syndrome is 1 in 2,400. That's at age 25. If I take a look at age 49, the actual odds go to 1 in 10. If the female has a child at 49, the odds are 1 in 10 it's going to have Down syndrome. What are the odds that I'm going to have a Down syndrome baby that's a boy with Down syndrome? Again, in this case, it's 1 in 20. So the aneuploidies that you went over last chapter, they really, really increase with the age of the female, not of the male, of the female. And you should realize that the main reason why is because the male, they make the fresh sperm cells every day, and the females, those are, you're born with them. And the longer they sit there, the greater the chance of an aneuploidy taking place. But the main thing is we were taking a look at multiple probabilities. And sometimes you guys try to add them. You don't. You multiply them to get the actual probability. Okay? That is the topic on the last part on 10.2. For your assignment on 10.1, I want you to put odds on the top of your page. That'll be worth 2 points. If you don't put that on top, you will not get those 2 points for the assignment I'm going to send out today for 10.1. Okay? Thanks. Stay safe.